So this is the video going over the Chapter 8 multiple choice. Okay, so number 1 was a bit of a doozy to start off with. So it was a 2 sample proportion, so it was going to be big and ugly. We had Golden Delicious minus Red Delicious. I found my p hats I was interested in, and subtracting them, you get 0.08. So really it's just that whole plug in all the numbers and calculate very carefully. And remember that the Z star comes from the fact that it's 98% confident. So you go to table B, last row of table B, and look that up. Okay, so you go through and calculate, and you end up getting this for your confidence interval. You might get something slightly different just because of rounding error, and that's totally fine. Now, here's where this problem gets kind of mean, not just, I don't know, tedious, but mean. Because they said, which of the following is closest to the interval estimate, blah, 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 and then numbers of apples. They didn't say proportions of apples. They said numbers of apples. So what we got here is our proportion of apples. But now you have to pay attention to the fact that there were 1,000 of each type of apple. So multiply by 1,000 to estimate the difference in the number of apples. So the answer is actually E, not B, which is proportions. We want E, which is a little bit mean. So be aware of that on the test. If they're asking you to calculate things, look to see, are you calculating the proportion like we usually do, or are they being tricky and actually asking for a number? And in that case, you might have to multiply by the population size at the end to get a number, not a proportion. Okay, number 2 was checking your conditions. And the 10%, so it's random. That first condition is good. The 10% condition is not good. If you do 10% of 200, you get 20. And 30, the sample size, is bigger than 20. So nope, doesn't work. And then if you check the large counts condition, here's the whole NP, N1 minus P, they're both bigger than 10, so that does work. So the only thing that failed was the 10% one. So the answer is D. Okay, for number 3. So this one is the whole what decisions can you make, what numbers are plausible according to your interval. So this is the interval they got, 0.46 to 5.2, which I'm imagining is like right here to right here on our number line. That's our interval. And we need to know which of these statements is supported. So which of these statements is true based on our confidence interval, like the confidence interval is evidence for which of these statements. Okay, so let's just kind of go through them. More than 90%, well, here's A on the number line. That confidence interval is not giving that. More than 60%, it's not. It is giving it for C, more than 40%. We're saying that the proportions are between 46 and 52. So 47, 51, 49.7, those are all plausible values in that interval, and all of those values are more than 40%. Fewer than 10 is too low, and fewer than 25, too low. So it's about which of those statements describe all the numbers in our interval. Okay, so number 4, let me show the whole thing. Whatever. Is that plug and chug with the algebra. So here's your margin of error equation. They told you that margin of error is 5%, so do put it in as 0.05, not as 5. It needs to go in as a proportion, not a percent. They did not give you a p hat to use. So in this case, you need to use 0.5 as a conservative estimate. So just remember that when you're finding the sample size, if they don't give you a p hat to use, you have to use 0.5, because 0.5 will mathematically give you the largest possible sample size you could need. So that's why it's considered a conservative estimate. So use 0.5 and then do all your algebra. You have to divide by 1.645. You have to square both sides. Then you end up with a variable in the bottom of a fraction. So I put the other one over 1 and cross multiplied. You could also multiply by n on both sides and then divide. Either way, you're going to get 0.25 divided by 0.000923, and you get 270.6. Remember, you cannot have 0.6 of a, what is this, person? Consumer. Yeah, you can't have 0.6 of a consumer, of a person. So you have to round up to the next one, 271. Okay, number 5 is again about that decision making. So if our confidence interval is between 42% and 48%, it's basically like here on a number line. And then we have to read through all of our phrases to see which one of those describe the numbers in the confidence interval. Which of these are true for all those numbers? So if all our numbers are between 42 and 48, like 47, 44.652, all of those would be examples. It is true that less than half, less than 0.5, more than 40%, yep, they're all bigger than 40%. Approximately 45%, so that is the point estimate, 0.42 plus 0.48 divided by 2. To average them, find the point right in the middle, is 45%, 0.45. Not more than 45%, because more than 45% is like right in here, right? And so it's saying these guys, but it's ignoring all the ones below that. We find it plausible that it could be 44%, 43%, 42%. Doesn't have to be more than 45%. And then more than 25% of all women, yeah, between 0.42 and 0.48, that is for sure more than 25%. Okay. 6, our confidence interval, it's about the differences again, right? And it's common that the number we're most interested in is 0, because a difference of 0 means there's not a difference between the two proportions. And so we're interested to know, is 0 in our confidence interval? So they said, the manager of the company claims that the revision of the procedure will change the proportion. So will change the proportion means there is a difference between them. That going from before to after, there is a change, which means they're not the same. So this is not supported because 0 is in our interval. They're saying it's plausible there's no difference between the before and after. So yeah. Okay. Number 7. Oh, another plug and chug. You need to have the right equation and plug in the right numbers. And this, again, was tricky because they wanted to know the interval estimate of the number of people, not the proportion, the number. So you did have to do all your calculations to get proportion. And again, because they're mean, they included that as a possibility. But you had to read the question carefully. And were they looking for the number? And if so, in this case, we had to multiply by 5,000 because that's our population size to get our actual number. And when I multiplied 0.32 by 5,000, I got 1,600, which is slightly different than 1,620. That's just rounding error. So I knew that one is my answer. Okay, I think that's it.